another problem about a beam. This is a beam subjected to tension. We know that if a beam will bend, the other portion will become tension, or the other part will become is in compression. Like for example, if it is simply supported beam, the upper portion of the beam is in compression, while the lower portion is in tension. So we have here an example, no, of a certain beam subjected to tension and compression. So we have a wide flange 16 by 31 section consisting of an 830/16. So if it is 830/16, you need to see 36 here is the 36 KSI. But if you convert that one with your FY, the FY there is 36 KSI. And if you convert that one, it is just about just equal to 250 megapascal. And ito 58 KSI is just equal to 400 megapascal. And that wide flange by 16 by 31 has two holes for 22 mm diameter bolt in its tension flange. So sa tension flange yan nasa iwan. So if it is supported beam, this is the beam that we have. Hindi siya may tension dire. So nasa iwan. Duha ka bolt, no? Two holes. So it is already stated there nga the flexural stress, the allowable flexural stress of the beam is equivalent to 0.66 Fy. So kini yun ang kuha na yung flexural stress. So given na daan yung flexural stress, so there's no need to find out what is the flexural stress by going to the other formula for the flexural stress in the steel. So from the handbook or from the manual of the EIEC, with regards to wide flange 16 by 31, these are the properties, the specifications. So ini sa specification in your copy sa inyong table. I inserted a portion of the table. So for this problem, we are going to determine the effective tension of the tension flange area. So tension flange, so the lower portion only. And determine the amount of the moment of inertia to be reduced due to the effect of the holes. So because of the percent of the holes, there's a reduction of moment of inertia. Then determine the safe concentrated load that it could support at the midspan beside its own weight if it has a simple span of 6 meters. So it is a simple span beam. So let's start with the number 1. Determine the effective tension of the flange. So first, we must know what is the area of the flange. One flange only, the flange that is only subjected to tension. So the area of the flange is just equals to the BF. BF is this one, no? Okay. BF times the thickness. Kana yung thickness, which is equivalent to thickness of the flange. So meaning the area gross of the flange. Area gross of the flange is just equal to the BF 140 times TE 11.2, which will give you an area of 1,500 68 mm square. It's the area of the plants, gross area of the plants. One portion lang because the other side is in compression and tension lang. Then the net area of the plants, the net is just equals to this gross area 1568 minus the two holes. No, minus the two holes. Then the two holes here is just equals to 2 times that hole is for the bolt of 22 mm, so it is 22 plus 3, no? Because it is a hole for the bolt na 22 mm, so it must be bigger than 3 mm times the thickness of the plants, which is equivalent to 11.2. So you have 1008 mm squared. Now there's an appropriation by the AIC Commission that if your 0. In our formula sa sa area gross o katong area net, no? That if your if this is if you times area of the plants lang, no? Net area of the plants is greater than 0.68y times area of the plants grows then there's no reduction of the holes needed. If this is the situation, then no reduction of the hole needed. So hindi na mag-deduct sa hole. But if it is otherwise, then if it is this one is smaller than that one, then you need to deduct the holes. So let us examine this one. So 0.5 FU area of the plant's net is just equal to 0.5 times your FU is 400. Area of the plant's net is this one, 1008. Then you have the answer of clean 201 600. That's the result. While 0.68 FY area of the plant's grows is equals to 0.60 times 250 times area of plant's grows, this one 1568. Then you have an answer of 235 300. So we will compare that one. So meaning this one is greater than 201,600. So meaning to say that kinesia is greater than this one. So therefore there's a need to consider the reduction. So there's a there's a reduction of the whole. So consider the reduction of the whole. So to consider the reduction by whole, we have another formula that the area of the plant's effective area of the plants, no, is just equal to 5 FY times the area of the plant's need over 6 FY. But this is CPU, no? This is CPU. Or we have the effective area of the plants is just equals to 5 times, so FU is 400 times area of the plant's need, this one 1008 over 6 times 250. Then you have the effective area of the plants is equivalent to 1,344 mm squared. So this is now the effective tension plants area. Kinesia. The effective, number one, effective tension plants area. Now, if there is no reduction, so if you try to look at the reduce siya, di ba? No, ikan sa flat 1 goes reduce siya. So, but even in case that this one is smaller than this one, then there's no reduction. So, we need to say your effective area is just equal to your gross area of the plants. So, we'll go to number 2. Determine the amount of moment of inertia to be reduced due to the effect of the force. So, gini atong kuan, no? Mo ni atong kuan sa holes na to. Moment of inertia sa holes. So, ang moment of inertia sa holes is just equal to the moment of inertia of ang kuan is just a moment of inertia minus the holes. Wala ni holes dito. So, we'll have the amount of moment of inertia to be reduced due to the effect of the holes, then reduction of plants area. So, you have a reduction of plants area. Pila na reduce sa plants area na to? is just equal to 1, 5, 6, 8 minusan sa akin eh. No? 1, 3, 4, 4. Or ang reduction na to is just equal to 2 to 4 mm squared. So muna yung reduction sa itong area. So muna yung area how karisa. Reduction of the plant's area. So to determine the moment of inertia of this particular area, so you will have reduction of moment of inertia. Is equal to define Ix. Yan ang kuha area 2 to 4 times times the square of the distance gikan sa neutral axis padulong sa center sa atong buwan diri, no? Center sa atong plants, no? So you'll have 195.9 squared. This is from the formula to sa transfer moment of inertia, pero it is a so this will yield an answer of by the way, duha may kabuk, no? Times 2. Yan po sa ibabaw sa times 2 ni sila. So you have 17.2 times 10 to the 6 mm to the 4th. That's a reduction of moment of inertia. So that's the number 2. Answer of the number 2, no? Muna yung reduction sa moment of inertia. Muna yung moment of inertia due to these codes. So, for number 3, determine the safe concentrated load that it could support at the midspan beside its own weight if it has a span of 6 meters. So, we need to say this is simply supported beam. Simply supported. So, nasa kahuling ang weight of the nasa kahuling ang weight, no? Then, at the midspan, ada load nga additional P at the midspan. So this is 6 meters ang midspan. You are told to find the value of P. So atong W1 ni or the unit weight of your steel, the unit weight of your steel, which is equivalent to 31 kips man siya, or 16 by 31, that's 31 pounds per foot. So 31 pounds per foot. So 31 pounds per foot. This is equivalent to, if you 31 pounds per foot, that's equivalent to 42. This is equivalent to 42, 46.2. 46.2. This is now kilogram per meter. That's equivalent. But take note, this is still kilogram. We will convert this to Newton mm or Newton meters because our stresses there are in megapascal. So you convert this to Newton meter. So you multiply this by 9.81. The gravitational force there. So it will give you an answer of 453.22 Newton per meter. Okay, so that's our W, or we can also say this is equivalent to 453.22 kilonewton per meter. So, our formula here sa atong moment, in order to determine the value P, you have this formula, the moment for this particular simply supported span is 1 W L squared. Plus na yun sa yung P sa moment sa aning due to the P, so plus P L over 4. Basta kay concentrated load at the mid span of a simply supported beam, then PL over 4 na siya. So i-plus lang yung dito. Or you can have a shear and moment diagram if you wish. In which you can go to your formula that moment, formula for moment with regards to the section is equivalent to MC over I, or you can also say that it is just equal to M over SX. So we will determine the net moment area. Now, considering that we have the reduction of moment area here, we will have net moment area. So atong net moment area karon, considering the reduction of this hole due to the moment, so you'll have our moment is this one, 156 times 10 to the power of 6. So, mo niya itong moment sa wide flange kung wala pa holes. Kung kaya na may holes, so may dirakan na ito sa yung holes. So, minus na ito, 17.2 times 10 to the 6. So, you have your net moment. So, you will have 1,3, the result is 138 times 10 to the 6 nm to the 4. So you will substitute that to this formula. So your moment due to your section is just equal. So we'll base our formula here again. This is the easier one. So we'll have your SX with respect to X axis is just equal to I over C, or this is equals to, your I is this one, no? 138 times 10 to the power of 6 divided by your C. Your C is from the neutral axis to the outermost fiber, which is this one. So over 201.5. Then you will have your SX. So your SX is equivalent to 688.83 times 10 to the 3 MNU. So from this one, from this formula, if V equals to M over Sx, then we can say that our M is just to FB times Sx. But what is your FB? FB is equivalent to, in our problem, is just equals to 0.66 of your Fy. So we can say this is now your N is just equal to 0.66, oh no, 0.666, no? 0.66 of your Fy. Fy is 250, so that's your FB times 688.83 times 10 to the 3. So you have your moment capacity sa anang beam is equivalent to 113.7 times 10 to the power of 6. This is Newton mm, no? Because this is mm, hindi po siya megapascal. So yun na siya, or we can also say nga this is equivalent to 113.7 will become kilonewton meter. So going back to this formula, we can equate this one to this formula. So you'll have 113.7 is equal to, this formula is 18 times your W is ini 0.453.23 kilonewton meter. Kung ano natin dito, 2 times the length 6 meters squared plus P times L na 6 over 4. Then you will have the value of P equals to 74.44 kilo Newton. Okay, this is now the final answer of number 3.